earlier though.
That's probably.
I didn't hit the right buttons. All right, you only had to do a few of these. There was only 8 you had to do total. This is a perfect example of what they're gonna ask you about converting Celsius to Fahrenheit, where I was talking about you don't have to be dead smack on because it's gonna be a multiple choice. 104, when I did it, it was like 40 point something, I believe. It was closest to only one of those, so 40 degrees Celsius. Number 4, we talked about, so I know, hopefully you realize, because we did talk about it at the beginning of the school year. We talked about, remember when we looked at this reference table on the bottom of the front, we labeled the crust as rocks, the hydrosphere as water, and the troposphere was a type of atmosphere, which is the air. So hopefully you realize that as we are going up through the troposphere, that warm air rising and the cold air sinking, that is number 4, convection. Number 6, I did officially tell you you could skip. You may already know that carbon dioxide is a greenhouse gas, and the more greenhouse gases there are, the warmer the temperature. So that would be answer number 2. While we're here, can you guys do question 7 if you haven't done it already? It was not required. I just want to see if you know how to figure this out. So everybody take a moment and read question 7 and figure out the answer. Gabe, what page 24? It's the only question number 7. So for this is a concept that we will go over, but it is something I need you to be able to think through and figure out on your own. So first of all, they did label sides. There's what's called the windward side. Hint, that's the side the wind is coming from. And then the leeward side is the other side. So it does say as the air moves down the leeward side. So let's start. Is air going to get warmer or colder as it's going down the mountain? Hey, guys, what's at the top of mountains? Snow. What's the temperature at the top of the mountain? Okay, it's always going to be colder at the top and warmer at the bottom. So going down the leeward side, the air is going to cool. Oops. Yep, now you got me confused. The air is going to warm up. And does air warm up because it's compressing or expanding? Warm up.
Oh, compressing.
Okay, so compressing would be like squishing together, so like cuddling. So molecules warm up when they're smushed together. So they will warm up due to compression. What you guys, I think we're just getting confused with is when I say warm, why does warm air rise? And that's because the molecules expand. So it expands because they're warm, but once it's expanded, they start to cool down. So when molecules expand, they then cool down. Sorry, my words aren't coming out right. All right, question 8 was the next one you were supposed to do. And again, it did use the word troposphere. Just know that that's part of the atmosphere. We will do a whole reference table on it probably next week. But as you go up in the atmosphere, we even talked about this yesterday, it is going to get colder and pressure is going to decrease. Number 10, again, good example of how these will be asked in multiple choice questions. Because when I did this on my chart, I really got more like 10, I think it was like 1020.8 or 1020.9. And that's only remotely close to one of these. So again, 1021 is going to be the answer there. 12 kind of made you think about it a little bit, but it did kind of go right along with what we were talking about, including my really good picture yesterday, where we had the person standing on the ground, and I asked you how much atmosphere was on top of them, and you told me the whole thing. Well, here they're telling you that whole thing is equivalent to 30 inches of mercury. And then they tell you they went up 3.5 miles and they got to 15 inches. Hopefully you notice that 15 is half of 30. So what that's telling you is the total mass of air, about 50% is less than 3.5 miles. So basically you cut the atmosphere in half, or the weight of the atmosphere in half, by just going up those 3.5 miles. Question 14 was the next one you were supposed to do. This one should have been no problem for you. As you increase temperature, density should go down or decrease. Answer 3. And we did not do the reference table yet for question 16. That's why you didn't do that one. Question 18 you could do. Pressure gradient. Remember, that's how close the lines are together. So the closer they are, meaning the gradient increases, the wind speed will increase. 20 we skipped, and 22 is the next one. An anemometer is used for wind velocity. Questions on any of the ones you had to do? 21 is at 1. So remember, on a hot afternoon, it's going to be hotter on the lake, or hotter on the land, colder on the lake. So since it's cold here, we're going to have a high pressure because cold air sinks. Warm air, we're going to have that rising. So yep, the wind is going to go from the high to the low. Anyway, we are going to skip what is a high pressure system for now. Get to relative humidity. So when we talk about weather, the stuff you guys always want to know, like if you are like, wonder what the weather's going to be next week, I have a softball game. The things you want to know about are always, what's the temperature going to be? Is it going to rain or snow? Will it be hot and humid? You might also want to know about the wind. So this is one of those variables that we like to know a little bit about and have a basic understanding. So this is where we're going to start right now. Relative humidity. I'm guessing you guys know the basics of humidity already, right? What is it? If you talk about the humidity, yeah, it's the water in the air. It's not quite that simple because it is officially called relative humidity. And if you can think of relative dating, like we talked about last chapter, it really needs to be a comparison. So it's a ratio or a comparison of how much water is in the air compared to the amount the air could hold. So it's not just a flat out number, it is going to be a ratio. Do you guys know what relative humidity is measured in, what units, or what label it gets? They're talking about the humidity outside. Nobody knows. Always given in a percentage. So that next, oh, we're not there yet. So it's given in a percentage, almost like your grade is given in a percent. And humidity is actually figured out very similarly to how I figure out grades. You just had a test. There was 28 questions on it. Do you guys know how I gave you a grade, like where the number came from?
Right at the top and bottom times 100.
What's the top though?
Whatever you got right.
Okay, so when I do grades, I do a ratio. So there were 28 possible points on the test. Let's say you got 3 wrong, so you got a 25 out of 28. That's a ratio, 25 out of 28. To get this into a percent, I take 25 divided by 28, multiply it by 100, and this would have been an 89% on the test. This is exactly how we figure out relative humidity. We measure how much water there is in the air, and we compare it to how much the air could hold, and we get a percentage. if this little, well, actually, this is kind of a big jug. If this jug here was filled about here, what would the relative humidity of this jug be? About 50%, okay? It could hold all the way up to here. It's only holding this much, so it's about 50%. Now I got a smaller jug here. What if this jug was filled up to here? 50%. So is it the same amount of water in this 50% as in this 50%? It's not. Just like when you take a test, if you take a 10-question test or a 100-question test, you could get yourself a 50, but in the 10-question test, you only got 5 wrong. In the 50-question test, you got 50 wrong. It's still the same percentage. So I just kind of wanted to point out kind of how percentages work real quick. So that's what relative humidity is. If you haven't already written it down, the next bullet is it's measured in percent. And then the next couple are just fill in the blanks here. What do you think we call it when the air is holding as much water as it can?
100%.
It is 100% relative humidity. There's a word for it. What if a sponge was 100% filled up? What would you say? It is wet. It is full. You're not wrong. It's saturated is the word I'm looking for. So when air is holding as much water as it can, the air is called saturated. And then I just reworded that when the air is saturated, the relative humidity is 100%. But then this last bullet here, this is the kicker. Cooper, you're with us, right? Put your phone down. Do the work. This last bullet, the third one here, is the one that I need you to make sure you remember. The warmer the temperature is, the more moisture the air can hold. I do need you to kind of understand why.
Molecules spread out.
Oh, okay, Cooper understands. Say it again, Cooper.
The molecules spread out says more than water.
There, okay, so when it's warm out, the molecules are spread out, kind of like right now, your desks are nice and spread out. See all the space in between the desks here, because they're nice and spread out? If you guys were air molecules, all this empty space would be room for water. But when you start packing those molecules in tight because they're cold and they cuddle, see what happens to the empty space when the desks start to cuddle? The empty space goes away and there's no room for water. So when molecules are nice and spread out, there's room for water. When they're cold and packed in tight, there's no room for water. And that's where these two different size jugs come into play. I always say that this big one is warm air. See, it's warm air because it can hold more water. This one's cold air. See, it's even labeled cold air. Cold air can't hold as much water. Do you guys like humid days?
No.
No? Would you guys all agree they're kind of uncomfortable? Now, what if I told you the humidity on this past Sunday was 100? Because it was. What was happening on Sunday?
So,
It was snowing. It was snowing on Sunday. How can we explain that the humidity was 100% if it's snowing?
it's
What?
cold air, so it's not like water.
It's cold air. So what? It doesn't take a lot of water to fill it up. Guys, what will happen when this jug is all filled up and I try to put more water in it? Okay, it's gonna overflow. What happens when the air's all filled up with water and we try to put more in it? It rains, or in this case of Sunday, it snows. Were any of you feeling that uncomfortable humidity on Sunday? No. And the reason for that is when it's cold out and you're filling the water all the way up, it's really not that much water. Versus those hot, humid summer days, When you're super uncomfortable, that's because 100% means this much water. So in those hot summer days, the amount of water the air can hold is a lot more. That's why we feel so uncomfortable in the summer, because there's literally more water in the air, even though it's still 100% humidity. Wow. So speaking of temperature and humidity, we got to put this on the graph. What do we put on the x-axis, Sirius? What goes on the x-axis if we're doing temperature and relative humidity? Temperature. We put the one I can control. I can say, oops, sorry, I guess I did not put a slide up here for that. So we're going to put temperature on the X because I can control the temperature.
Is the graph linear or did it kind of like it?
Yeah, it is. And then we've got relative humidity here. When I go from a cold air to a warm air, I don't change the amount of water. What happens to the relative humidity? It does decrease. So this was all the way filled up, starts at 100%. When I put it in here, is it still 100% filled up then? No. So when you warm up the air and don't change the amount of water, the relative humidity will go down. All right, there are two instruments that we use to measure relative humidity, and they're both right here. And because I can't really spell them really good, we're gonna go straight to the PowerPoint again. That first one is a hygrometer. And the second one I can pronounce better, it's a sling psychrometer. Go ahead and label those both, please. Sling psychrometer and a hygrometer. They just both measure the amount of water in the air. And let me show you the one we're going to be using in class, or actually in lab, you're going to be using these. They look like this. They look just like the picture. If you can't tell what it is, we've got, okay, maybe you still can't tell what it is. It is a really cheap thermometer. In fact, it's two of them. But one of them, what do you see on the bottom of this one? It's a little piece of cloth. We call it a sock because it looks just like the socks you put on your feet. And to measure humidity, you got to do something first. You got to get that sock wet. What do you think we call it now? It's literally a wet sock. That's what it's called. So to operate these, we have to get one of them wet. The other one stays nice and dry. Now the one that's dry is just going to measure the temperature of the room. What is the water going to do?
Then change the temp of the other one.
The temperature is going to change, but why?
It's something with the moisture.
Okay, it's something to do with the moisture. Now let's talk about let's get you guys wet. Go in a pool. Get out of the pool. Especially, and then get out of the pool and then run a lap around the pool real quick while you're soaking wet. How's your skin feel? Cold. Or if you don't want to run, get out and stand in front of a fan, soaking wet. How's your skin feel? Cold. Why does your skin feel cold when your skin is wet and you get out of the water? What happens to it?
Change the temperature.
Why?
Oh.
How about this? Why do you guys sweat? To cool down. But how does sweating cool you down? What's the sweat do? Okay, your body's now wet, but does it stay wet forever? Where's the water go? It evaporates. The process of evaporation takes heat out. Guys, you're being very distracting again.
Cleaning that up, please. What's up to do with my pen?
the process of evaporation gives off heat. It takes heat out of the substance by evaporation. So what we're gonna do now that this is a wet sock, by the way, I didn't use it at like cold water, it's just regular room temperature water. But once it's wet, I'm gonna spin it around like this. You have to spin it for like 2 or 3 minutes. What is spinning going to do to this wet sock?
Dry it off.
It's gonna help dry it off, which where does water go? It evaporates. Again, the process of evaporation will cool the temperature down. So that second sock is going to be cooled by evaporation. And that's how a sling psychrometer works. We're gonna then put that onto a reference table and we'll figure out exactly the relative humidity. But while we're working with relative humidity, we're also gonna have to talk about dew point. You guys heard of dew before?
Mountain Dew.
Yeah, not Mountain Dew. Where do you find dew?
Grass.
On the grass. So what do you think dew is? It is moisture. It is officially condensation. I'm not sure if you officially know what condensation is yet. It's a notes for another day, but it doesn't come out of the plants. No, it's
No.
not the plant sweating. It's not a product of photosynthesis. Yes, photosynthesis does give off water, but the dew on the grass is not from that. The dew on the grass is very similar to when you have a cold piece of glass and you go with your hot air. What's on the window? Fog, right? You guys know that? Okay, that's what dew is. Dew is water coming out of the air. So guys, what's the relative humidity if the dew or the water is coming out of the air? What is the relative humidity if the dew is coming out of the air? It's got to be 100%. It's full all the way. So the dew point temperature is the temperature at which water comes out of the air. It is also the temperature at which air is 100% saturated, or is 100% or saturated. Those two things mean the same thing. When water is coming out of the air, the relative humidity must be 100%. When you're done with this, you got to grab your reference table and open it up to page 12. The last thing we're going to do for today.
Is it often that like when it's like super hot out, the relative humidity is 100 or?
So when it's hot out, it doesn't necessarily have to be. Around here, we are very humid. So it's not 100, but it's usually around in the 80s. But the reason why it feels so yucky is because that takes a lot of water to make it 80% humid when it's warm. But because of Lake Erie being so close to us, we do have pretty humid temperatures. So to find dew point and relative humidity, like I said, we are going to use the sling psychrometer. So at the top of the next page, just 2 vocab words there. So top of page 34. Go ahead and write the dry bulb, wet bulb, and then can you add the third bullet here underneath? And it's called the wet bulb depression. So the dry bulb will just measure the actual temperature. And like I said, the wet bulb is the temperature of the air cooled by the evaporation. It'll just be the wet sock. And then finally, the wet bulb depression is just really how much the temperature has been depressed or lowered. So really, it's just the difference between the dry and the wet. All right, so now we're gonna go ahead and use E ESRT page 14 to do a couple of examples of how we're going to use it. So, like I said, I said page 12. I lied. I did not say 12. I said 14. Yeah, please change that to 12 if you already wrote 14.
We said we're on 12.
Yeah, I really want you on page 12, but I've been screwing my page numbers up all day. That's what I thought. So, 12, I'm not sure. It's 12. On page 12, you should see something that might remind you of one of these multiplication charts from back when you were a little kid. Do you remember using multiplication charts? If I asked you to do 8 times 7,
356.
okay, but use this chart. What do you do?
I can't. Go to 8.
Go to an 8, go to a 7 or 8 and 7, it doesn't matter. Bring your fingers together and you're at 56, like you guys knew. Page 12 of your reference table works exactly the same way. So one thing I will point out, on page 12, there are 2 charts that at first look the same. The top one, before I speak out loud, I will double check. The top one is the dew point chart. The bottom one that looks just like it is the relative humidity chart. Can I please tell you, do not mix those 2 up. You'll get very wrong answers if you use the wrong chart. So when you're looking for the dew point, go to the dew point chart. And you can see, just like the multiplication table, there is a set of numbers going down the left side. This one's labeled dry bulb temperature. There's also a set of numbers going across the top. It's not the wet bulb. What is it? It's the difference. Please circle, underline, highlight, star, difference. By the way, what math do you do for difference?
Subtraction.
Okay, subtract. Always subtract the bigger number from the smaller number. Which one's always going to be bigger, by the way? The actual temperature. So the dry bulb will always be bigger. So to do this, you literally find the dry bulb, find the difference, bring your fingers together, and you're going to get the dew point. Relative humidity works exactly the same way. The charts are the same. So again, still says difference, still says dry bulb, but you'll see very different numbers on the inside. So let's give this a whirl. Can you do this first one that's on page 34? It says, if the dry bulb is 20 and the wet bulb is 15, find the dew point and the relative humidity. I actually left I did give you a blank for that. So let's do the dew point first. So what number do I point to on the dry bulb side? 20. The actual air temperature. What number do I point to on the top? 5, not 15. You gotta do the difference. I guarantee you, you will all make that mistake. Don't. Stop and think first. The top number is the difference. So 20 and 5. Bring your fingers together. You also point to 12? If you had done 15, you would have gotten over into one of these white spots. If you ever get into a white spot, that is your guarantee that you did something wrong. Not all of them will give you a white spot though, so you might just end up with the wrong answer if you don't subtract at the top. So the dew point in this case, so the dew point should be 12 what, by the way? Dew point is not percent. Okay, these are, and you can see it up here at the top, it says dew point degrees Celsius. So dew point is the temperature at which water will come out of the air. So what that means is, if everything else stays the same and the temperature drops from 20 to that 12 degrees, it's going to start raining. Now let's do relative humidity, same problem. So you got 20. What number do we point to on the top? 5. Bring your fingers together. What do you point to? 58. And what are the units on that number? Percent. All right. I think you guys get the point. No homework tonight. That's it.